Today's lesson is about solving multi-step inequalities. Your learning target says, I can solve multi-step inequalities accurately. The second part of this I noticed has a typo. I can determine how many solutions an inequality has. So as we've talked before, solving inequalities is really no different than solving equalities, other than if you were to multiply or divide both sides by the same negative number, you would have to flip the sign. So looking at this example, we would need to distribute first. So we would take 5 times n. I'm going to change this to a -3. And 5 times -3 is -15 is greater than or equal to 3 times n, and 3 times 7 is 21. All right, I want you to pause me while you go ahead and solve this and come back to see what my solution is. So you will see that up at the very top, I decided to remove the 3n from the right side as my first step, but I could have started anywhere. So just because you have different work does not mean you did it wrong, as long as you have the right answer. So I removed 3n from both sides, and that left me here 2n plus a -15 on one side and 21 on the other. I needed to separate these, and because I have the constant on the other side, it's the constant that I moved. I added 15 to both sides. That got me down here, 2n on one side, 36 on the other. I divided both sides by 2. Did not flip my sign because that's a +2. So my solution is n is greater than or equal to 18. If I had asked you to graph this, you would have a closed-in dot, and you would have shaded everything greater than and including 18 on your number line. I want you to pause while you do both of these. When you are ready to see my solutions, you will come back. So here's my solution. You will notice that my very first step was to distribute. And then I decided that I would remove 2 p's from the left side. You could have started anywhere, so your work might be different than my work. That's okay as long as you got the right answer. So when I remove 2 p's from both sides, I'm here. I have 5 on one side and p plus a -18 on the other. I need to separate these because the constant is over here. That's what I'm removing from the right side. So I'm going to add 18 to both sides. And I ended up with 23 on one side and p on the other, and I did not switch my sign. Now, I don't necessarily like it when my variable comes second. So if I want to flip that around and have p come first, I just had to make sure that the alligator mouth was open towards the 23. So either of those is acceptable. Here is my solution to the second problem. Notice that I distributed first. After distributing, you could start anywhere you wanted to, but I decided that I was going to remove my -2k. That left -2 on one side and -16 plus 7k on the right. I need to separate these because my constant is here. It's the constant that has to move. So I'm going to add 16 to both sides. That got me here. 14 on one side, 7k's on the other. Divided both sides by 7. And I was left with 2 is greater than k. I did not flip my sign because there was no multiplying or dividing by a negative number. But I don't like my variable to come second, and so I just flipped the whole solution around. My alligator mouth was open towards the 2, so I left it open towards the 2 and said k is less than 2. It's time to see if you can take what you've been learning and apply it to a word problem. So I would like you to solve and graph this situation. It says at a bake sale, students charge 25 cents per cookie, brownie, or cupcake. Some parents donated money rather than baked goods. Donations totaled $18. The students earned at least $46. What was the least number of desserts sold? So you will pause me while you write your inequality, solve it and graph it, and when you're ready for my solution, you will come back. So when I was thinking through this problem, I know that they were going to make 25 cents for every treat, and they had $18. So on one side, we're talking about the money for the bake sale. So that's the 25 cents times the treat plus the $18 donations, and that was at least. So that means it could be equal to, or it could be more than the $46. So I subtracted the donations first. I took off the parent $18 from both sides. That left just the treats on one side and $28 on the other. I divided by the 25 cents for every treat, and I came up with 112 treats. When you go to graph that, 112 goes in the center, one more, one less. It could be equal to, but the number of treats is probably greater than, as well as equal to. So here's your graph. So let's start talking about number of solutions. I do have a note page for you, and if I forgot, which I may have, just try to remember to ask me for that. So when solving multi-step equations, we usually have one answer. For example, the Carlton Company budgeted $1,825 for a banquet. The cost of the facility is $225. How much can the company spend per guest on food if there is also, that should say also, a $3 charge per guest for linens and there are 80 guests coming to the banquet? So to set this up, the company has to pay $225 for the facility, and there are 80 people coming. They have to have food and the linen charge. And all of this has to equal less than or exactly $1,825 because you can't go over budget. So if we distribute, we'd have $80 times the food and the $240 for the linens. All that has to be less than or equal to $1825. We can combine these two. So 225 plus 240 gives us 465. So we have the $80 per person for food, and this is the rental and the linens together, $1825. So all I did was I combined this number and this number. All right. So let's take off the 465. That's the constant. That's not going to change. That leaves $80, or I'm sorry, 80 people times their food has to be less than 1825 minus 465, which is 1360. Divide both sides by 80. And it looks like the food per guest has to be less than or equal to $17. There is one solution to this problem, but that is not always the case. Sometimes there are problems that don't have any solution. So let's look at this one. If I were to distribute first, the left side is unchanged, but the right side has 32 and 8 W's. If I start by eliminating or removing 8 W's from both sides, I'd have 14 on one side and 32 on the other. That will never work. It doesn't matter what your variable is. It will never come out correctly. And so don't have your answer be 0. 0 can't be your answer. Your answer is the null set, or a 0 with a slash through it, or you could say there's none. Sometimes things just don't work out. And then one other thing that might happen to you is that there are an infinite number of solutions. So again, if I were to distribute, I'd have negative 6r's and negative 8 on one side. And if I combined these, I'd have negative 6r's and a negative 8 on the other. Those look exactly the same. If I have the same thing on the left and the right, it doesn't matter what I have for my variable. It will always work out. And in that case, your answer is